Hello students, welcome to classroom. So today we'll be discussing numerical problems on power of lens. So the topic power of lens has been discussed in the previous video. So this is a continuation from the previous video. So there are a handful of questions in the textbook. Some example questions are there and exercise questions are also there. I will be discussing the exercise questions, question number 16 and question number 17. So it's a very simple problem. Power of lens, you have only one formula. So if you know the formula, the calculation is very easy. So let's start the video and let's calculate this question together. So let us first read the question. Find the focal length of a lens of power minus 2.0 diopter. Minus 2.0 diopter, you read it as minus 2 diopter. Okay, minus 2 diopter. 2.0 is 2 only. What type of lens is this? So we have to find the focal length. So the question wants us to find the focal length. Okay, so we'll have to find focal length, which will be F, and then they have given us power. So P is provided to us, capital P, because power is represented by capital P. And then we also have to identify what type of lens is this. This we can even do now. Okay, class, we can even do now. Now, why do I say that we can even do now? Because, see, power can be either positive or negative. Okay, power can be either positive or negative. Now, you have to know that which type of lens has which type of power. If I ask you, which type of lens carries positive power? Now, there are only two types of lenses, concave lens and convex lens. So, do you remember which type of lens carries positive power and which type of lens carries negative power? Yes, convex lens carries positive power and concave lens carries negative power. So, positive will be convex and negative is concave. So, you can easily answer this question. What type of lens is this? Look at the power. The power is negative. That means the lens is a concave lens. So, okay, identifying what type of lens is this is very easy. Okay. Now, in the same way, calculating the power is also not that difficult. So, let us start calculating. So, the first thing we write is given. So, what do we write here? The things which are given to us, we write. So, given to us is power. So, P is given to us minus 2 diopter. Okay, minus 2 diopter. You can just write minus 2 only. So, just write minus 2. Then, we have to find focal length. So, F, question mark. Okay. Now, the power for focus, the formula for power is P is equal to, okay, let's rewrite this again. P is equal to minus 2. Write the formula for power, which is, formula for power is P is equal to 1 by F. So instead of writing P, we will write 1 by F. So P, you replace it with 1 by F. So write 1 by F and write here minus 2. Alright, what do? You go cross multiplication. So you can put here 1 and then do cross multiplication. Reminding again that this X, okay, don't do it with pen. You can do it with pencil and erase it, okay. I am showing this to help you know the pair for cross multiplication. So F will cross multiply with minus 2. So you get F into minus 2. This is one pair and you'll get 1 into 1, which is 1. Okay. So F will be here and then 1 will be there. Minus 2 will go below 1. So you get minus 2. Now denominator will not carry the sign. So this sign, we can give it to the numerator. Okay, remember, denominators, they don't carry sign. Okay. So what we have to do is, we just have to divide this one. So 1 is to be divided by 2. Okay. So 1 is too small, needs help, put point, give him 0. So 2 5s are 10. Finish. So put here 0. So the focal length is 0.5. Am I forgetting something? Or is this the final answer? Yes, the sign. Okay. So don't forget the sign, minus 0.5. Okay. So power is negative. That means focus is also negative. Power positive, focus is also positive. Alright. So are we done? No. Now you have to write the unit. You have to write the unit. You have to write a unit. Okay. Focal length should always carry a unit. So what should be the unit? Okay. The unit should be meters. Remember, the unit should be meters. Okay. So questions on power, okay, whenever the question provides you with power, okay, now the unit will be diopter. So by default, don't forget to put here meters, okay. So the final answer should be minus 0.5 meter, okay, m for meter. So this is the focal length. Find the focal length. We have just found the focal length. So this is the focal length. And the last part of the answer, what type of lens is this? So for the last part of the answer, you write the lens is identified. The lens is identified to be what type of lens is this? It's negative power is there. That means concave lens. Concave. The lens is identified to be concave, or we can write concave lens. That's it, class. So this is it, okay. So this is the numerical on question number 16, simple numerical, okay. Question number 17 is also same. So now we'll discuss question number 17. So I'll be writing the question, and after I'm done writing the question, we'll solve the numerical together. So we are done with writing the question. So let's read the question first and then we will solve the question together. So question number 17, the question reads, a doctor has prescribed a corrective lens of power 1.5 diopter. Find the focal length of the lens. Is the prescribed lens diverging or converging? So on reading the question, we get to know the power. The power is 1.5 diopter. Now students, pay attention to the sign. The sign is positive. So now remember, which type of lens carries positive sign? Yes, it's convex lens, okay. Now if you are able to answer that question, you have already answered the question to this question. You have already given me the answer to this question. The question is also asking to identify whether the lens is a diverging or converging lens. So now you have to know one thing, okay, and I'm sure you already know that, which type of lens is known as converging lens and diverging lens. So here I have drawn both the lenses, convex lens and concave lens. So this is convex, and this is concave. Now you tell me which type of lens, okay, is diverging. Is it concave which is diverging, or is it convex which is diverging? Yes, it's concave. So concave is diverging. Concave lens are also known as diverging lens. Why? Because in concave lens, the light after undergoing refraction, okay, they go like this, okay, they go further, they split further away from each other, so they are known as diverging. Then that makes convex lens as converging. So convex, converging. Now why are convex lenses also known as converging lens? It's because the light rays after refraction, they converge together, they meet at a point, so they come together, they converge at a point. That's why they're known as converging, okay. So now you can also answer this question, is the prescribed lens diverging or converging? Since you have already given me the answer that it is convex, so the answer is converging. See how easy it is, okay. So we are done. Now we just have to do one thing, which is find the power. So we first write whatever things are given to us. You write given, and what is given to us? Power is given to us. So power is given to us, write capital P and write 1.5 diopter, okay, 1.5 diopter. Just write 1.5. It's positive, okay, no need to write, okay. Then we have to find focal length, okay. So power formula, remember power formula, I've already given you. Power formula is reciprocal of focus. So instead of writing P, you write 1 by F, and then whatever value is given to us, 1.5, okay. Now what I will do is I will remove the decimal, okay. 1.5, I'll remove the decimal. So 1 by F, let it be, and 1.5, let's write it as 15, okay. 1.5 on removing the decimal will be 15, but if you remove the decimal, there should be a 0 in the denominator. So how many zeros? Yes, 1 0. So 1 0. Now what you do? You will do cross multiplication. So go for cross multiplication, okay. So F will pair with 15, so F into 15, and then 1 will pair with 10, anything multiplied to 1 is the number itself, so you'll get 10, and f into 15, f will be here, and then 15 will go below 10. So what you do, you cut with 5 3s are 15, 5 2s are 10. So what you're getting, 2 by 3, so you're getting f equal to 2 by 3. So that means we have to divide 2 by 3. So 2 is divided by 3. 2 is very small compared to 3. 2 needs help, give him help, put a point, he gets 1 0. So 3 nearest to 20, so 3 6 are 18. Okay, and then 20 minus 18, you get 2. Again, only the point is given, so you get 0. So 3 6 are 18 again remainder 2. So we know what's going to happen. It's going to go on like this. Okay, so what we will do, we'll just select the first two, 0.66. So here 0, so 0.66, you round off this number. Okay, you round off the second number with the help of the third number. So the answer will be 0.67. So f, you will write f as, so f value will be 0.67, and we'll have to write a unit. So what unit should we write? It should be meters. By default it is meter. So this is your answer for focal length. Okay, so we have just found the focal length, and then is the prescribed length diverging or converging? Then what will you write? You write here, the given length has been identified as, which length is it? Converging length. Converging length. You can just stop at converging, or you can also write converging length. So this is it. Okay, my dear students, we have come to the end of the chapter. Chapter 9 gets over. So I have followed the pattern. So I have tried to cover up almost everything. So students, you can always refer to these explanations and the questions which have been solved, especially the numericals. So let this serve as a notes for you. And then the next lesson, which will be chapter 10, Human Eye and the Colorful World, I'll be starting this in the upcoming days. So look forward to those videos. And then likewise, I will be covering each topic, each chapter sequence wise. Okay, I will not hurry to complete and leave incomplete videos in middle. No, I'll follow a sequence, and whatever lessons I start, I'll make sure that I complete it. Okay, so that it will be beneficial to students and to everyone who is watching these videos. So thank you all for tuning in and for your valuable support and for watching these videos. Continue your support. I need your support. And then you can refer these videos to your friends who are in class 10, because these videos will mostly benefit them. So please do that, and then I'll see you again in the upcoming videos. Thank you all, and God bless you all.